Welcome everyone. My name is Sean here from Subquery. Excited to be here to present this workshop for between Boba and Subquery on data indexing. In the next 20-25 minutes or so, we're going to quickly go through what is Boba, what is Subquery. We'll take a look at the problem and the solution overview provided by Subquery. And then most important of all, we'll jump into a real live demo actually and show how this works very quickly.
Great. Thank you, Sean. So, Boba Network is a multi-chain layer 2 optimistic rollup that aims to unlock the potential of rollup technology and enable interoperability between blockchains in the real world. The protocol is fully compatible with EVM-based tools and has already been deployed on Ethereum and BNB, supporting lightning-fast transactions and low fees.
Let's take a look at the challenges that developers are facing when developing on the blockchain. So the main problem is actually where and how to get blockchain data to drive the amazing applications, the mobile apps, the decentralized or dApps that they are creating. So this is where Subquery comes in, because Subquery is essentially an end-to-end blockchain indexing solution. Now, it actually solves Subquery provides three different areas or components. The first one here is that there's an open source data indexer, which is fast, flexible, and reliable, providing any developers with the ability to build custom APIs for their Web3 project across a number of networks, which I'll show you shortly. There's also a managed service solution from Subquery for those looking for a centralized infrastructure hosting provider. Now, obviously, when you create a particular Subquery project, you can host it locally, you can host it on, say, Google Cloud, AWS, or in this managed service provided by a Subquery as well. The advantages include a dedicated database, redundant clustering, intelligent multi-cluster routing, etc. And the final piece of the puzzle here is the decentralized marketplace, which is powered by an SQT token, allowing participants to buy and sell blockchain data. There are network participants such as indexers who offer indexed or RPC data. There are consumers who consume the data, and also delegators who can stake their tokens in the network and benefit in the growth. So a lot of people may be wondering, why Subquery? Well, there are several benefits and advantages of using Subquery as an end-to-end blockchain indexing solution. First of all, it's open source, as mentioned earlier, meaning that the code is available for inspection and auditing. There are bounties awarded for bugs, for instance, to make the code base more robust. It's very easy to get working. To get up and running for the first time, there's a starter template, which I'll be showing in the demo. And using Docker, you can get it running in a couple of minutes. It's also very simple because to start indexing your project, you only really need 3 files to be modified before index data is returned. It's also highly customizable, where you can get the exact blockchain data you need when you need it in your when you specify your schema file. It's also fast because you only index the data that you need. It's also feature rich because there's the ability to scaffold your project, for example, via an ABI contract in the EVM world. There's also syntax discovery, there's historical state querying, and lots more as well. It's real time because you can access a blockchain data as soon as they appear on the blockchain. It's also multi-chain by design, and this is quite an important and a popular feature as well, where a lot of developers now are trying to aggregate or get data across different blockchains, and the Subquery project makes this really easy to do. And then when you have this data, you can aggregate it and then present it all within one Subquery project in this unified API, so to speak. It's flexible. As mentioned, you can self-host, use our managed service, or participate in the decentralized network as a data provider or a data consumer. And then finally, it's EVM and WASM compatible. And this means that you can access blockchain data across a wider range of networks, in particular, the large Ethereum ecosystem. And you can see here the supported networks. There's over 150 now, uh, quite a large support in Polkadot, and then the EVM network that's constantly growing. And of course, Cosmos, we're very popular in Cosmos, and a couple of smaller ones down the bottom here on Algorand, Near, and Stellar as well. Okay, so in particular with Boba, there is a starter project inside the Subquery GitHub repository. Uh, for those who are interested, there's the link here, or the QR code that you can scan, taking you directly to the code base. And this is the one that we'll be going through today. Now, if you are following along or you want to give this a go, there are some prerequisites required. First of all, you'll need Node.js, and you can download this from the Node website, or if you're running Brew, Brew installed Node will install it pretty quickly. You'll also need Docker as well. Obtain this from docker.com, or Brew install cast Docker. And then the final piece of the puzzle is the subquery CLI. And this is where you'll need npm or the Node Package Manager, install-g for global at subquery CLI. Now, to actually get this project up and running, there are 3 simple steps. Once you've initialized your project, which we will do so shortly, you want to define the shape of the data that you want to index. And this is done inside what's called a schema file. In here, you'll define the fields that you want to index from the blockchain. Step 2 of 3 is you want to define or configure your endpoints and the filters within what's called a manifest file. This will tell the project the endpoint, so where to get the data from, and there's a filter to get the exact data that you need. And finally, once you've got the data, you want to transform it in the mappings file using TypeScript, after which the data is stored in a database, in particular, Postgres, for instance, in this example. Okay, so in this particular project overview here, what we'll do is we'll show you how to index all transfers and approval events for the wrapped Boba on the Boba BNB network. There are 2 networks. There's an Ethereum and EVM one within Ethereum, and then there's the BNB one as well. So a couple of QR codes here for access to the actual code, and also the guide or the quick start that you can also follow along with at a later date on our Academy website. So with that, let's now jump into this very quick demo where I'll go into VS Code. However, just a quick note, this is the Subquery GitHub repository. If I do a quick search down here for, say, Ethereum or ETH, you'll see that there is the Ethereum Subquery starter project. And it's in this directory here where you can see a number of quick starts. And if I go to Boba, you'll see the 2 options, BNB starter and ETH starter as well. So if I click on this, you'll see that there are some simple instructions on how to get up and running. But let's go into VS Code here. And what I'll do is I've got my terminal open. Let me make it a bit bigger. And then I'm going to run some simple commands. The first one being subql init to initialize a project. And this is from the CLI that was installed previously. So let's call this Boba test project. Like so, I could name it anything really. Hit enter. And then I get a selection of network families, EVM networks, Algorand, Cosmos, etc. Let's choose the EVM network, hit enter. And then you can see there's BNB Smart Chain. If I scroll down a bit, there's the Boba network. There's a whole bunch here. So let's go to the Boba BNB mainnet, hit enter, and you can see there the BNB starter project, enter for that. And then all of a sudden on the left-hand side, you can see a scaffolding project directory appear where a lot of the hard work has been done for you. Next up in the steps, the RPC endpoint, what I'll do is I'll just hit enter and accept the yellow default parameters here. So this is the bnb.boba.network RPC endpoint. Hit enter for all these, accepting the defaults. And then my project is complete. Now there's a neat feature here where you can see it's asking if I want to generate scaffolding from an existing contract ABI. So if you've got an ABI file or an application binary interface, you can actually load it in here, and a lot of the project will be created for you as well. But I'll start from scratch and hit in for no, and there we have it. Now, the first thing you want to do when you've got this project is you want to cd into the project folder, and you want to download the dependencies. So let me go npm install, and this will take about 30-40 seconds. And while this is downloading, let me go ahead and open up what's called the schema.graphql file. So this is where you define the shape of your data. So here we've got what's called two entities. We've got the transfers and the approvals entity, and we're indexing the ID, which is the transaction hash, a mandatory field because it's got this exclamation mark, the block height, and some values such as to, from, value, and contract address. And very similar down below with approvals as well. So you can create as many entities or objects as you want. And you can think of these as database tables with the fields as the columns within the tables itself. So this is your starting point where you're defining the data that you need. The next file that was mentioned is the manifest file or the configuration file, where if I scroll down, you can see we've got the name, the description, and scroll down further, the specific chain ID, and in particular, the endpoint here. So this is where the data is coming from. And note that it's an array. So I can actually specify multiple endpoints. So if there's an issue in one of them, the project will go and rotate to the next endpoint and try that as well in a round robin type fashion. You can then specify the start block. So we're going to start indexing at around 18.4 million, just because I know there's data there. If you want to start from the beginning, you put one, the Genesis block, but it could take a bit of time. The address here, this is the smart contract address for the wrapped Boba contract here. And then down below, we've got some handlers and some filters where we're going to filter out on, as mentioned, all approvals and all transfers as well. Now, if I don't have a filter, effectively, I'll be indexing the entire blockchain, and that could take some time as well. So we highly recommend creating filters and handlers to get the exact data that you need. Okay, so the dependencies have been downloaded. The next thing we want to do is go ahead and run npm run script code gen to generate our TypeScripts. And then after that, we want to go ahead and build the code as well. Okay, so once this is done, the next command is basically to start Docker. So I can go start Docker like so. And if I just show you very quickly, I go into the package.json file, you'll see that I ran build or cogen build and start Docker. I could have just run dev. If you're running yarn, you go yarn dev or npm run script dev, and it'll actually do all those three previous commands in one line. So it's a real time saver. I've got Docker running in the background, so let me hit enter here and find my Docker screen. And what you'll see is that it's going to start downloading 3 images. I can't expand this, unfortunately, um, or enlarge it, but you can see that there's a Postgres database image, there's the subquery node image, and then the GraphQL engine as well. So give that a minute or two, and you can see that it's starting to uh, index some blocks here. Now, what you'll notice is that there's actually a couple of errors down here. So let me just stop this, Control C, and you'll notice that in the error, it says invalid response, batch size exceeded. Please reduce the batch size. So um, sometimes the RPC endpoints, they can be rate limited. Um, they might have certain requirements. So what I'm going to do is reduce the batch size. And I can do that by going into my Docker Compose file. And then scrolling down, there's a configuration setting here where I can set the batch size and the number of workers as well. So let me just dial this down so I don't smash the endpoint. And we'll go, say, 5. Let's save this. And then I'll just run Docker again. And this should work. Now, while this is running in the background, let me jump into localhost port 3000, which is what we term the playground, or where we will go ahead and run our sample query. Enter. There we go. Now, if I jump into the README file, you'll see that there's a sample GraphQL query that I can use. I'll just copy this out. Paste it here and hit run. And you can see that we've got some data coming back. This is live real time, so I'm pretty glad that it worked. And it's you'll notice that I'm just querying for the first 5, right? And you can see I've got the ID, the block height, the from address to address, and the value being sent. So that's pretty much it in a nutshell. People might be wondering, well, how do I know this data is correct? Well, we can cross-check by jumping into the Boba Explorer here. So let me copy out the ID first of all. Top, jump into the Explorer at bobascan.com. I'm going to paste in this transaction ID or the transaction hash. Oh, there we go. Let me expand this a bit. Now we'll do a quick comparison where we're looking at block height, a couple of addresses, the value. So let me check out the from address. That's 62C3. Go down here, the from address, 60, scroll down a bit down here in the actual transfers itself. So 62C3 from, and the value, you can see it's 5,000 wrapped Boba. And down here it's 5,000 wrapped Boba as well. So this is just to 18 decimal places, I believe, particularly how it's represented in the Ethereum space. So you can see that the value matches. In a couple of minutes, we've basically spun up a Docker image to index some data from the Boba network. Now, just a quick note, the subquery network is the next big thing that we are rolling out. It's a decentralization and tokenization of the network, where you can completely decentralize your application stack and incentivize your community to run your infrastructure. So we've got Kepler, which is live at the moment. We can scan the QR code and take a look at that. It's actually quite an exciting network here, where a lot of participants can go ahead and contribute. If you want more information, there's a link and a QR code to the documentation site at academy.subquery.network. And there's also documentation on Boba's website as well, so docs.boba.network. Lots of rich information there to understand more about the network. So that's pretty much it. Let me just round up by providing some contact details here. Subquery.network is the website. There's a whole bunch of links at Linktree, taking you to lots of useful resources, and in particular, the Discord community here, very active, very helpful to help troubleshoot or provide any advice that you'd want. And also the Boba.network website as well, and then the Boba's active Discord community. So with that, thank you so much for your time. It's been a privilege to be here to show you how Subquery works, how it works with the Boba Network. So thank you very much.